So far we have worked with the multiplication property of radicals. The multiplication property of radicals tells us that the product of two square roots is the square root of the product of the radicands. In other words, I can combine two square roots into a single square root. I can see this property used in reverse. In other words, if I have the square root of a product, I can separate that into the product of two square roots. So if I want to find the square root of 20, I don't know what the square root of 20 is, but I know that 20 is 4 times 5, so that would be the square root of 4 times 5, which would be the square root of 4 times the square root of 5, and 4 is what we call a perfect square. Okay, and 4 is a perfect square because we know that the square root of 4 is 2, so that would be 2 times the square root of 5. Okay, so why don't we talk for a second about perfect squares? Perfect squares are such numbers such as the square root of those numbers are whole numbers. So let's talk about perfect squares that we know. 1 is a perfect square because the square root of 1 is 1. 4, the square root of 4 is 2, 9, 16, 25, 36, 49, 64, 81, 100, 121. Okay, so these numbers are perfect squares. In the same token, x squared is a perfect square, right? Remember that the square root of x squared, if x is a positive number, the square root of x squared is x. The square root of x to the 4 is x squared. So if we have even powers, these expressions x to the n is perfect if n is even. Okay? So if we have something like x to the 7, x to the 7 is not perfect. Okay, so how do we use the property of radicals to simplify radicals? Well, a radical expression is going to be considered simplified if there are no perfect squares in the radicand. Okay? So we have to eliminate all the perfect squares in the radical. So if I have something like the square root of x to the 7, right? Well, x to the 7 is not perfect, but x to the 7 can be written as x to the 6 times x. So if you subtract 1, you can represent x to the 7 as the product of two expressions, and one of them being a perfect square. So according to our property, that's the square root of x to the 6 times the square root of x. And remember that the square root of x to the 6, all you have to do is divide this number by 2, the exponent. So x to the 6, the square root of x to the 6 is x to the 6 divided by 2, right? It's times the square root of x, and 6 divided by 2 is x to the 3rd. So it's x to the 3rd square root of x. Okay? So let's go and see what happens when we have 27 x to the 7 and we want to find the square root of that. So 27 is not perfect, but 27 can be written as 9 times 3, right? And the good thing about 9 is that 9 is perfect, right? 9 is perfect. Now x to the 7 is not perfect, but we can write x to the 7 and x to the 6 times x. Okay? So now what I'm going to do is I'm going to rewrite my radical, and I'm going to put at the front the perfect. So 9 is perfect, x to the 6 is perfect. Everybody else, the 3 and the x, are not perfect. I'm going to leave them here. And now what I'm going to do is I'm going to divide this into two radicals, right? And one radical for 9x to the 6, and the square root of 9x to the 6 is 3x to the 3rd, and then this radical stays like that. Okay, so this is 3x to the 3rd square root of 3x. Okay, so let's just do a few problems, a few examples, and in this example, these 5 examples, we're going to simplify the radical as much as possible, and we are going to be eliminating perfect squares in the radicand. Okay, so square root of 18 is not perfect, but 18 is 9 times 2. right? And 9 is perfect. So that would be 9 is going to kind of come out of the radical since 9 is perfect, right? Or the square root of 9 is 3. So that would be 3 square root of 2. Okay? The same thing with 80. 80 is not perfect, but 80 is 16, which is perfect, times 5. Square root of 16 is 4, so this could be 4 square root of 5. Okay, so these are the answers here. Okay, x to the third is not perfect, but x to the third can be written as x to the second times x. And remember, x to the second is perfect. The square root of x to the second, if x is positive, is x. So I have x square root of x. What about the square root of w to the 10? Well, 10 is even, so the square root of w to the 10 is going to give me an expression with a whole number as an exponent. So I'm going to divide the 10 by the 2, and that's 5, so that's w to the 5. Okay, now let me go here. 12 is not perfect. 8 to the 5th is not perfect. So I'm going to write 12 as 4 times 3, and I'm going to write 8 to the 5th as 8 to the 4 times a. So we can see what's going to happen. I'm going to put the perfects at the front. 4 is perfect, 8 to the 4th is perfect. I'm going to put them at the front. And then these numbers right here that are not perfect, or these expressions that are not perfect, I'm going to put them at the back. So 3 and a. Okay? So what I have now is this comes out, this comes out. The square root of 4 is 2. The square root of 8 to the 4 is 8 to the second. And then I'm left with the radical 3a. 2 squared radical 3a, or square root of 3a. Okay? So remember, when we simplify the radical, we try to eliminate perfect squares in the radical.